Hi, this is Margo. This is Sunday afternoon, early evening, September 10th, 2023. I hope everyone is safe and doing as well as possible. And another week has passed, and I'd like to welcome everyone to the show tonight. This will be my weekly update that I'll be putting on YouTube, and we go into detail on climate-related items, and especially methane and sea ice, and then other things as well. And this is for my YouTube people. And what I've been doing just in the last couple of weeks, I've started going over comments first, and y'all seem to like that. And so I'm going to do that, and then we'll move on. And these shows tend to be long, but just watch it in stages if you want. But we'll go into detail on everything. And we're still we're at the end of the melting season for the Arctic sea ice, and we've got about another week, maybe a little bit longer on the melting. Just depends on the weather, and I don't know how warm the water is underneath the ice and things like that. But we're going to get started. So I've enjoyed interacting with y'all with the comments. It does add a little bit to the show, but I think it's important that we have some interaction here, because this is a classroom. This is how I started out, just exploring on my own and just recording the videos as I found out how to, look at a certain website, and it took off. Y'all seem to like it, and so here we are. And so I'm going to start with these comments from last week's video, and from Kevin NZ, Kevin NZ1. I think that's Kevin Hester. Thank you for your diligence and time, Margo. You're welcome, Kevin. Thank you for being here, and thank you for the kind comment. And then Hey Jude just put a heart and little prayer hands. Thank you, Hey Jude. I appreciate it. Thank you for being here. And then Ed Tremblay says, if you get a chance, check out what's happening on the eastern Siberian shelf. It's a shallow shelf which probably has methane hydrates beneath the ocean floor. I'm sure there's more methane hydrates in other areas of the oceans on our planet, possibly in the Antarctic also. I enjoy your videos immensely. Thank you for all the effort, because it's totally appreciated. Thank you, Ed. I appreciate you being here. And as for the East Siberian shelf, we're not seeing huge releases there right now. That usually starts getting more active in the wintertime, supposedly because as the water refreezes on top of the warm water underneath, it traps the warm water underneath the thin layer of ice, and then heats up the sea floor and releases the clathrates. That's the theory. So we're not seeing a lot right now over there, but I do have here's an image. This is from Sam Carana, and he uses this image, and it was taken from a paper from Shakovas, Samilitov, and Shuvalin, and it's And so the blue areas are methane hydrates. This is in the Arctic region. Here inside this red rectangle is the East Siberian Shelf, the ESAS, East Siberian Arctic Shelf. This includes the East Siberian Sea and the Laptev Sea, and it's all along the coastline of Siberia up to the Taimyr Peninsula. And so we're not seeing a lot of huge activity there. What we are seeing is here, this group of islands. This is Severnaya Zemlya, and this is Komsomolets right down here. And here, I'll blow it up, and you can see. And it's right, and we've been seeing methane billowing and just hemorrhaging all around this Komsomolets area for, I don't know, 2 or 3 years now. It kind of waxes and wanes at certain times, but is generally going off all the time. And then we're also seeing right now super high releases in the Barents Sea, and I think it's mainly streaming off of the land here from the Scandinavian area and into western Russia. But wherever you see the blue, this is methane deposits in the seafloor that they know of. And so this is just in the Arctic. And see, it's even this whole Baffin Bay, this whole area coming down inside Severnaya Zemlya, Franz Josef Land, and down to Svalbard, Barents Sea, here in the Norway Sea, and then around the North Pole. And see, coming around this 80-degree north latitude line, and pretty much all of the Beaufort Sea and coming over. So this is just in the Arctic region, like I said. And this is from the paper, and here's a quote. Okay, we got to zoom out to read the quote to get it all here. Here's the quote. I can't read that word. Okay. Releases could potentially increase by 3 to 5 orders of magnitude, considering the sheer amount of CH4, which is methane, preserved within the shallow ESAS seabed deposits and the documented thawing rates of subsea permafrost. So this was a while back that this image was published. And there's so much permafrost that's thawing in the summer season of the northern hemisphere. A lot of Russia, in fact, almost all of Russia has permafrost. A lot of Canada, Alaska, those are the main areas. And then subsea permafrost as well. But also, you mentioned also that other areas with methane deposits in the seafloor, and I looked one time and found that on almost every coastline they found huge methane deposits. And I know there are a bunch around Japan, and they're actually drilling those and getting the methane for fuel. And so Japan is hot on that. But yeah, it's on all the coastlines. I didn't see one coastline where there were not huge methane deposits. So, and it's shallow along the coastlines, so there's that. So I'm gonna just minimize that in case we want to come back to that. So thank you, Ed, for that. And see, these comments trigger all kinds of things we can talk about. And then Larry Taylor, bonsoir, Margo et merci. You're welcome, Larry. He always greets me when he starts watching the video. And then once he watches it, he always leaves an interesting comment. And here's his comment. There's a lot of talk about the aerosol masking effect since 2020 with the sulfur in the bunker fuel being taken out. You've been monitoring CAMS for over 6 years. Have you noticed a change, especially over the North Atlantic? That is one chart where I have no idea with the colors. So you're talking about sulfur dioxide. Yes, I've seen the overall levels go up for sulfur dioxide. The overall background levels have gone up, and on one thing we're going to look at, which is strange that's happening, and I'm thinking the sulfates are coming down, either coming down out of the atmosphere, or I don't know what, or maybe there's plate movement releasing sulfur dioxide from the planet, but we're seeing some really high sulfur dioxide readings right now over North America, and we'll look at that in a second. Now I'm on my 6th year of monitoring on CAMS. I haven't been doing it over 6 years. I started learning CAMS in April of 2018, and that was when I put up my first teaching video on that, and I have a link to that video in the description box below. That was my first discovery video that I put up. And so at that point the color ledgers were different, but that also triggered me to go and see like the difference just in methane, which I track all the time. This is on my website, and it's in the Subscribestar archives, and I have everything archived over here. I'm a couple of months behind archiving right now, but I eventually get everything moved over from Subscribestar to my website for permanent, and it's all public, and you can go back to any day and see what methane looked like. And I started this in 2019, and so if we go to 2019 methane report for CAMS data for Monday the 9th, and this was on September the 10th. So this is exactly 4 years ago, and we can play this, and we can blow it up, and the color ledger is the same. Oh, I need to hit play before I blow it up. I think I messed up. Here we go. Alright, now And I don't know. This is see, this is the old format on CAMS too. And this is just a silent movie. I don't do a speaking video for every single day of methane. Okay, you saw the chart there. It's the same as what we have right now, but we can see here. I'm going to pause it. See, the background colors are lower. See the green, and this was the exact same time of year, and but see the high readings coming up off of Russia here and here in the Barents Sea, and this is, but it's much worse right now. It's much worse, and the background colors are higher because methane has gone up since then. And if we go where am I? Oh, hang on. See, like here we are for the CAMS methane data for today. See, it's pretty much the same color ledger. They've added some differentiations in there, but it's basically the same color ledger. And see here, the background colors are into the light green, lighter green, and see, we can see this whole area from Norway and up. This is much worse. Russia is worse here. We've also got Komsomolets billowing, and we've got you know, from the UK in this area coming up. So there's that comparison. And see, it's in the aqua there. And so this is interesting to see. This is just a short little silent movie, like I said, and they're about 4.5 minutes long. But you can go back and see what it was. I have every day recorded, every day that has been available. That's been my mission, is to, well, one of my missions is to record the CAMS so that if there is a blowout, you know, we'll see it. We will see it, the blowout. And now look at this background color. This is the North Pole view, and see the navy blue as the background color in the southern hemisphere, and that's a lot lower than what it is right now. And so this is as a result of methane going up. And we've got really the same problem areas with the releasing of the methane. They're worse. Like for instance, at this point where we weren't seeing high readings of methane in West Texas and through the central part of the U.S. that's always coming up now. Wow, look at this. See the background color here? This is, that's a big difference, isn't it? And because right now we've got the 1860 is which is this color up here as the main background color for the southern hemisphere, and we've got the greens coming further south right now. So, you know, this is the best way to compare. And and when I first started looking at CAMS, there was a different color ledger, and then they changed it in December of 2018, and it's the color ledger that's there now. And this is total column, so that was a big difference too. So anyway, I encourage you to to check out my archives for anything, and see, this is from September 2019, and it's the Subscribe Star archives on my website, margoshealingcorner.com. And so there's that. So okay, back to comments. I could do a whole show just on the comments. So thank you, Larry. Thank you for being here and being a supporter. And then Angel's Place says, thank you, Margo. You're welcome, Angel's Place. And then Climate TV 911 says, could you tell a year for methane eruption? It's erupting. It's not a year for it. I mean, it's erupting more and more. And he says, I think it will be next year with super strong El Nino plus solar max plus loss of ice albedo plus aerosol termination shock. Everything is coming at once. I guess you're talking about the methane bomb going off. You know, I'm not really predicting when. It could happen any time. I mean, we've been expecting it to happen any time, but like I said, it might be even more likely to happen in the winter time than in the summertime because of the trapping of the warm water under that thin layer of ice after the refreeze. And then Climate TV 911 leaves another comment. That's really a heck of coverage. Thanks for all hard work that you put in. Subscribed. Well, thank you, Climate TV 911. Thanks for subscribing. I hope you enjoy the shows, and you know, welcome here. It's a small community, but you know, I have loyal followers here, people who have been following me from the beginning, and then people that I picked up along the way. And you'll notice that I've got the comments set to be held until I review them and approve them, and that's just to keep the riffraff out, and so that the comments are relevant to what we're talking about here. So welcome, and thanks for being here. I appreciate it. I hope you enjoy the channel. And I'll go ahead and put my plug in. I am not monetized. If you see ads on my videos, it's just YouTube putting up ads to try and get some money, but I'm not monetized, and I don't make any money off of the YouTube channel. Couple of ways you can support me. I have I've got the PayPal link in the description box below, and I also have a Subscribestar page, and that's kind of like Patreon. And I'll show you, here's my Subscribestar page, and this is what it looks like for me as the creator. And when you log in, you would see all of these posts. You won't see create a post, but you'd see all of this. And it's subscribestar.com/Margo, and for $5 a month you can join and support my work. And I post things on a daily basis, like yesterday I posted earthquakes, and then I track the methane on a daily basis, and report on it for CAMS and NOAA data. I don't report every single day, but I do report the data from all the days. And so, like, here was an update that I put up yesterday for the most recent methane data. Here was a show I did on Friday for the methane data and other things. And see, this is the ozone hole over the Arctic. See, I report on lots of different things. I track major earthquakes. I also do a midweek update on Wednesdays, and it's a mini version of my Sunday show. And so we look at methane and sea ice and other things too. So that's in the middle of the week. And then, I post all the sea ice data from that day as well. And so these are all things you can have. Whoa, forbidden. Why am I forbidden? Oh, I think because I've got a VPN running. But anyway, these are all the things you can have access to, and you'll get an email every time I put up a post. So we'd love to have you over here. Anyone, $5 a month to help support my work and to get all the latest. So there's my plug. Now let's get into the show. Let's see, that was 28 minutes. I could do a whole show just on comments, like I said. So we're going to start here with Climate Reanalyzer. Oh no, I want to start with I am tracking the hurricanes, and we've got 3 hurricanes in the Atlantic here. This is Zoom Earth for right now. This is near real time. It's only like says 5:40. It's 6:01 right now. So within 10 or 20 minutes, this is satellite views. And so here's Hurricane Lee in the Atlantic. This is Hurricane Margo with a T, and it's in the mid-Atlantic, and it's turning north now. It's not going to intersect with Lee as far as I can tell. And then here's a low pressure area. This is new 97L, 97 low. Margo is a tropical storm right now at 65 miles an hour, headed north right in the middle of the Atlantic Ocean. And here's Hurricane Lee Right now it's at 120 miles an hour, Category 3 major hurricane. And let's go here, zoom in, and it's right here just above these San Juan, Puerto Rico, these islands here, Guadalupe, Anguilla. These are Virgin Islands down here, and then the Bahamas over here on the west. And it's a humongous storm. Here's the eye, but it's just north of those islands, and then it's tracking northwest, and then they're showing it making a north turn Wednesday at 11 a.m. and 115 mile an hour forecast, still Category 3. And then Thursday it's still headed pretty much straight north, 11 a.m. It's slowing down to the Cat 2 at 105 miles an hour, and then headed a little bit northeast Friday 11 a.m. and it's slowing down to a Category 1 hurricane, 90 miles an hour. This is their forecast, and this gray area is the impact of the storm with the rain. Let's see this gray area here, and right now it's set to make landfall up here in around New York, and then Massachusetts, Maine, New Hampshire, and then Canada, Newfoundland there. That's what it's set right now. And also we can look on Climate Reanalyzer. This is hourly forecast map, and I'm going to refresh to get the latest start time. And initialization. Okay, here's our latest start time for today, and this is hourly forecast maps, GFS Global 10-day, and I've chosen the North Atlantic view, and this is precipitation and sea level pressure map. And so for the North Atlantic for 10 days, and it's by the hour. So if we hit this arrow, we can watch the movie here. So here's Lee heading, and then here it makes a north turn. There's a cold pocket of water that it runs into that was left over from Idalia, and I think that's what slows it down. But it is making landfall up here in the northeast of the U.S. And see, here's Margo out here in the center of the Atlantic, and it just, what does Margo do? It just kind of stays in the middle. And then it hovers. And then, it's just kind of zigzagging, and then it goes off to the east and dissipates. But Lee is the one we're tracking here. Let's see, here it comes. Here it comes. And then okay, I want to stop it here where it starts going north. And this is, let's see, you can go backward or forward. Why is that not working? Oh, everything's kind of slowed down because I'm running a VPN. Because NASA Worldview wouldn't come up without me on a VPN. This started this week with the whole just a black screen, and then I turn on my VPN and I can see NASA Worldview. So I'm running VPN right now. So here it is. This is on what day? This is valid for Friday the 15th, where it's going north. But there's already rain up here. This is from another system. Let's see, so this whole east area. Okay, and then if we hit play again, there it goes. Okay, it's coming in for landfall. Look, right here, and here's Maine. Anyway, you get the idea. Here's Pennsylvania, there's Delaware, here's New York, here. Here's Long Island, here's Rhode Island, Massachusetts, New Hampshire. I mean, wait, one of these is Vermont and New Hampshire. You get the idea there. So let's go. Here it comes. So, yeah, it's coming in at 970 barometric pressure, HPA. So there's that. Another thing you can see on this, but it could go further out. I mean, this is just a model. This is their prediction. You can also see precipitable water or accumulated precipitation. I like this one because you get an idea of how much rain they're going to get. And see, it's raining right now in this whole area. So here we go. Here comes Lee. It's slow. It's going slow. See, it's raining all around there. But the heaviest is, right around the eye here. Look at this. So this East Coast is all going to be getting rain in the meantime. This is from a different storm, and then here's Lee, and here's the rain coming in from Lee. Look how this spreads out with the accumulated precipitation. Now this is still over the ocean, and then here it comes, here it comes, here it comes. So landfall on Saturday. Looks like Saturday the 16th. And then it's going over. There's on Sunday. Rain, rain, rain. This is tedious, I know. But look at all this rain. That's incredible. Let's go. Look. Here, we can do it like this. Time lapse. And so, see, these areas are getting up into the red. And that's, look at this. The dark is 12 to 16 inches. That's a lot of rain. Let's see, the purplish, that's 12 to 16. And then the dark purple is 16 to 20. Then it moves into reds, and so on. So there's that. But Margo's just going to stay out here in the Atlantic, and then here's more coming, the 97L. So it's hurricane season. So there's that. Alright, so we saw the hurricanes. Here's my hurricane report. Okay, Climate Reanalyzer. This is 2-meter maximum temperatures for today. This is air temperature around the globe, and we're seeing colder air over Greenland and Canada and the Arctic basin. It's below freezing as far as the air, and then green's still around it, and then so here's some warmer. See the reds up here in Canada. See, it's heating up in the south here, and here's the flat view. Here's South America, lots of whites. Africa, mainly in the north side, lots of whites. Saudi Arabia, Middle East, Pakistan, India, and the whites are 40 degrees C or higher, or 104 degrees Fahrenheit or higher. Here's 2-meter temperature anomaly, and this is for air temperature. And even with the colder air over the Arctic, it's still warmer than normal. We're still in the browns, and you know, this is like 3 to 4 C higher than normal, and then you start moving, 3 to 6 C higher than normal, and then you start moving into the darker browns. That's 6 to 10 C higher than normal across this whole, from the UK up along the coast, along Russia here, and then Canada, Alaska. See, we're getting back in the browns here, and in the US, browns on the west side, blues in the middle. That's colder than normal with the blues. Here's the flat view. And so all of Europe is warmer than normal here. A lot of Africa, then coming across Pakistan, north of India, a little bit of China. A lot of Russia is in the brown and then blues. Australia, you're half and half, brown and blue. And the Antarctic, okay, South America, you're mainly brown. Then the Antarctic is heating up, and I want to show you that. Here's the Antarctic right now. And so here's the West Peninsula, and here's the north side. This is over the Ross Ice Shelf and the interior and the Ross Sea. So we're moving into reds here. So, you know, that's like 18°C higher than normal. And the sun is coming up. This is at the end of their winter season. So, the sun is coming up. A lot of the interior is still in the dark. But, you know, it's heating up. Definitely heating up. Here's our overview. Worldwide, we're up 0.88°C, higher than normal. The northern hemisphere is up 1.09°C. The Arctic is up 2.02°C. The Antarctic is up 2.78°C. And the southern hemisphere is up 0.66°C. And the tropics are up 0.89°C. So all of our levels are in the plus zone, so that's higher than normal. The Arctic and Antarctic are almost the same. In fact, the Antarctic is warmer than the Arctic as far as warmer than normal. And so when you see this, the poles like this, both warmer than normal, and then northern hemisphere and tropics almost the same, and worldwide also, we've got runaway heating going on. Here's precipitation and clouds for today. The green is rain and the blue is snow. And so we've got rain here over the Barents Sea. Now, this is all ice-free right now. And we've got rain here over Russia. We've got some snow here over the Laptev Sea, and some snow just north of Greenland. And we've got some rain here in the Beaufort Sea. This is ice-free where it's raining. And some snow here at Greenland. And then, of course, well, here's the system on the eastern seaboard right now, and then here's Hurricane Lee. And so there's that. And here are the jet pieces, what used to be the jet stream. And we've got multiple loops, multiple lines, and this used to be like the polar vortex, but see, it's spread out and very loopy. And then look at this, we've got an extra one coming from the Pacific and up across the US, and then up the Atlantic and up into Russia. So it's broken, and so we've got parallel all these loops and lines, hairpin turns. I mean, this is totally out of the ordinary for a normal jet stream. We don't even know what a normal jet stream looks like anymore, because it broke and it's not gonna fix itself. It's only gonna get worse. Okay, we'll look at sea ice in a minute. And here's sea surface temperature anomaly, and this is for yesterday, the 9th, here in the Arctic. Mainly we've got browns right around the sea ice here. We've got reds and pinks in the Kara Sea, and our color ledger goes up into white, which is 9C higher than normal. The pink is 7 to 8C higher than normal. Then we've got reds and browns in this Barents Sea and North Atlantic. And then here's our evil eye here in the North Atlantic off the coast of Newfoundland. This area has diminished a little bit, but it's still, it's like it's getting hotter though. And this blue area, this is colder than normal. This is like here, like around 1C lower than normal. And this was after Idalia went across Florida and came up a little bit of the eastern coast and then went out to sea. But it picked up the warm water and then brought the cold water to the surface. So this is why I think that's my theory as to why we still have this colder water here. And this is, I think, what is going to slow down Hurricane Lee, because it's right around here is where it starts turning northward. Because other than that, I mean, you've got all these browns, the water much warmer than normal. And right now where it is out here in the Atlantic, it's warmer than normal. Same with Margo out here. And here our Gulf of Mexico is all brown. And so on. This whole west coast of North America down along Baja is all brown. Here's the flat view in the Atlantic. You can see it's all in some shade of brown pretty much, except for this little blue, and then blue down here off the coast of Africa. And it's brown all the way up to the ice edge of the Antarctic. Indian Ocean. We can see the Mediterranean has cooled down a tiny bit. We're seeing a little bit of blue in the middle. The Black Sea is still brown. Caspian Sea is brown and blue. Persian Gulf is brown. Red Sea is brown and blue. And here in the Pacific, coming off of Japan, it's in the reds and pinks. Here's the Pacific here, and here's the equatorial Pacific high region. Now this has gone down. This had been red, but it's kind of spread out and it's brown now, going all the way across. And what had been our blob up here in the northeast Pacific is kind of toning down to just a brown. But you can see this this evil eye from Japan is spreading out. And I'm thinking that's from the dumping of the more dumping of the radioactive water, the waste that's going into the Pacific Ocean, that's heating up the ocean. And you can see up here in the Sea of Okhotsk, that's in the browns, and heavy brown around Kamchatka. So there's that. Okay, now we'll move to methane. And we'll start with the NOAA methane data. And this is for yesterday, the 9th, 1000 millibar level, Met-Op-B satellite in the morning. The mean or average was 1,844 parts per billion. We've got a little bit of missing data from along Greenland and South America mainly, and a little bit in the UK and Spain and part of Europe, and part of Africa, but I'm not going to worry about it. I'm going to count this, and it could be that it made it even a little lower, but whatever. In the afternoon, the mean was 1847. On the Met-Op-C in the morning, the mean was 1847, and we can see we've got some missing data over Australia and Papua New Guinea. I'm not going to worry about that. I'm going to count it. And in the afternoon, the mean was 1847. And, just pockets of this white missing data, no data, in addition to the gray, which is QC fail. But it is what it is. So, it's not like half the planet in the white like we see sometimes. And the mean is in range with what we have on the other ones. On the 487 millibar level, Met-Op-B satellite in the morning, the mean was 1925. And in the afternoon, it was 1931, so that went up. On the Met-Op-C satellite in the morning, the mean was 1895. Let's see how far south these pinks are coming. Down. This is the Indian Ocean here, and over the Arctic too. And in the afternoon, the mean was 1898. So we're starting with our weekly chart for just the Met-Op-C satellite 487 millibar level, and the 9th averaged out to be 1896.50, and that's an increase this week of 3 parts per billion. So here it's gone back up. And we're tied with, we hit this level on August the 5th as well. So we're not at the end of the methane rising season. Usually it peaks out sometime in mid to late October. Let's see what happened this week. We ended last week at 1893.50. That was a decrease of 1.5. And then on the 3rd and the 4th, I threw that out. I recorded it over here, but there was so much missing data, I just didn't want to record it in our readings over here to count. And then the 5th averaged out to be 1895.50. So that was an increase of 2.0 since the 2nd. And then the 6th was no change. The 7th went down 0.5. The 8th, no change. And then on the 9th, it went up 1.5, giving us an overall increase this week of 3.0. And then for all 4 readings, for 487 millibar, it averaged out, the 9th averaged out to be 1912.25, and so a slight increase of 0.25 up here. And then I'm tracking 1000 millibar. This is the first year that I'm tracking 1000 millibar, which is surface level, and it's quite a bit different. I think, you know, once it gets up in the atmosphere, it's more accurate. Kind of spreads out where we can see the trends better. Okay, so on the 9th, that averaged out to be 1846.25, and that gave us a decrease of 0.25 over here. And so far this year we've gone up. We started at the end, at the end of the rise season. I don't even know what the high actually was, because they changed their model towards the end of October. And so from where we started at the end of October, we were 1885.0, and then it went down to 1865. So we went down 20 parts per billion over the winter, and now we're above 1896. So we have surpassed where we were at the end of the rise season. Here we were. That was at the end of June. No, wait. Yeah, sometime in June. And now we're at 1896 from 1885. So far we've gone up like 10 parts per billion. And we've seen that trend on a yearly basis. If you go back and look at some of my old shows, I'll show you. I have everything here on this one spreadsheet. This was the old. This was the old chart from March of 2019, and it was just the Met-1 satellite, because they retired the other satellite, and so this is the only way I could track the data. But you can see here, and this was at 470, well, really 469 to 477 millibart. Wasn't quite at 487 where we are right now. So, see the trends. We would go to each year. Like here was 2019, where we were low, and here's the lowest in the wintertime. Here it's going up, 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 up. Here's where it peaked out in 2020, and then here's winter, and then it goes up, 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 2021. So it always goes up higher than the highest peak before, the year before. 10 to 15 parts per billion higher. And same thing. And here was 2022. And it peaked out well, the last reading we had here, it peaked out on October the 13th at 1951. But this was at a different level in the atmosphere. But these are the trends. See, so there's that. And I'm going into extra detail since I know I have some new subscribers, and I know it's going to make the show extra long. So you just break it up into pieces and watch it. Okay, here's methane forecast on CAMS, Copernicus Atmosphere Monitoring Services. And our base time and valid time are both for Saturday, September the 9th. And we're starting with Arctic area and surface level. And so the data is for Saturday, and the forecast period is Sunday, Monday, Tuesday, Wednesday. So you can see these background colors are quite a bit higher than in the 2019 video. Here's Comsomal, it's still billowing. Look at this from Norway over, and Russia's filling up here. And see, here is this East Siberian Arctic shelf, the ESAS, and we're just not seeing a lot of activity here. It's just streaming over. It's streaming off from on land. We're not seeing a lot just popping up like the difference here, like it comes from Comsomal. See what I mean? And also there's a hot spot in the North Kara Sea. But this ESAS was where Igor and Natalia focused on their research in the shallow areas. And we are seeing some like yellows, like see right here, it's in the yellow region coming up. But that's definitely not a blowout. And like that yellow is 2020 parts per billion. But like I keep saying, I think that the reason we're not seeing people talking about this at Comsomal is because this is probably part of Russian military territory, along with Novaya Zemlya and Franz Joseph Land. So, I'm thinking all of this could be off limits for them to really go and do a bunch of research. Also, I mean, this is a range, and this range, this dark area is, what is it, 2160 to 10,000 parts per billion. And it could be so high that ships might sink. There's not enough oxygen in the water there. I don't know. I mean, that's just a thought. Okay, Alaska's filling up here. That's because it's heating back up. Here in Canada, on the west side, here's North Dakota. That's a constant area. Here, south of the Hudson Bay, and in the U.S., pretty blobby. See, coming across. And remember, they're getting rain, and so you're going to see higher methane levels or readings once you've had rain and then add heat to it. In Texas, see, South Texas and West Texas, California, all these are blobby areas. So there's that. Now we'll go to the North Pole view. And here, the UK, Ireland, they're filled up. And it's just a big blob all the way over to Germany and this whole area in Europe. Here's the Persian Gulf that's filling up. Here's India, China. Here's Mexico. And see the greens. Look at these waves moving across. That's super high methane. Where you see these waves moving out. Here's South America. And then the global view. Now, quite a difference to what we saw on the 2019 video, huh? See the background color? And it's the same color ledger. And right now, our main background color is this 1860 parts per billion. And what we saw in the 2019 video, it was 1800. So that's 60 parts per billion higher. So that makes sense. That's about the difference. The difference it would be in 4 years. If you go up 15 parts per billion each year, that's 60. 4 years, that's 60 parts per billion higher, and that's what we're seeing. So, I've been recording this enough. We have historical data we can go back to and compare, and yeah, it's really going up. And see, the greens are further south. See, greens all the way down here. Alright. And, you know, if it weren't for y'all's questions, I wouldn't be so inclined to go back and do all these comparisons. So I just kind of focus on the task, the daily task here at hand. So it's good for us to reflect, you know, on where we've been, to get an overall view. Here's 500 HPA, so this correlates to the 487 millibar level on NOAA. And look at the heavy. See, it's stretched out across Africa and all the way up into Russia. It's kind of broken up, but in these bands. But look, here it is over Canada and the Arctic there. And higher readings coming further south. See the yellows and the reds. And then total column. Big difference, huh? Look at this heaviest area, and that reading. See, it's a range. Here it is. It is this range is between 1820 and 2320. No, 1920 and 2320 parts per billion, and that's methane added up through all the layers. So here it is, the highest, big blob from China all the way across India, southern Asia, across Saudi Arabia, into Africa, even up here into Iran, and all these reds. So there's that. Now I want to show a couple of more things from Climate Reanalyzer. Here's sulfur dioxide today. And if we go back to look at old videos, there were mainly blues as the background colors, and now it's up in the greens. And this is what I was talking about here, the higher readings. See this here, let me blow this up. Now this is from Popocatépetl in Mexico, the volcano. Now look at this. This is following the Juan de Fuca plate line. You see that? Just off the coast of Canada and the US, and then it spreads out down here and then spreads out across the US. So this disturbs me to see this, because I don't know what the source is of this. I'm thinking plate, it's either a plate movement and it's high sulfur dioxide readings, releases coming up from the Pacific plate and the Juan de Fuca plate, or it could be sulfur dioxide falling from the sky as sulfates, as we start reducing the sulfate emissions. Look at this. Look at that. It follows the coast of Canada. This is 500 HPA, So it shot up in the atmosphere, and then see it's heaviest right across the U.S. And so the Cascadia subduction zone is here, and you know, if we had plate movement of the Juan de Fuca plate and the Cascadia subduction zone, that could be releasing a lot of sulfur dioxide. But why would it, you know, spread out like that? You know, unless it's caught up in the jet piece. But that's very disturbing to me, because there are no volcanoes going off up here that would cause this, and it's not earthquakes. It's that's not the earthquake signature for sulfur dioxide. Then we've got it, some streaming up in the Atlantic, or coming up around Greenland there. And then here's the ozone hole today over the Antarctic, and this is going down 4 levels in the danger zone. The dark black line, anything inside the dark black line is in the danger zone, and we're going down 1, 2, 3, 4 levels here. And if you look on CAMS, you can go, this is where I get all this information. You can go here, and here's the color ledger, and for the danger zone starts in this kind of bluish purple area. That's 200 to 220 Dobson units, and then the blue is 175 to 200. The darker blue is 150 to 175, and then this navy blue is just above the black. The navy blue is 125 to 150, and then the black, when we get there, is 100 to 125. And then if you see a white hole, it's below the 100 Dobson units. And anything below solid yellow is 300 Dobson units. Anything to the left of the yellow, which is green and blue, is less than healthy. You've got a hole. It's a hole there. And just so what we have, so just to compare, I pulled up, this is ozone from September the 10th of last year, and here's what it looked like. So it was a solid ozone hole over the Antarctic, and it went down 3 levels, but it's all in the danger zone here, and it went down 3 levels, see, in the danger zone. So it's more of a circle, but what we've got this year right now, it made a donut and then it spread out, but it'll cover it. So it's bigger, and see how it's going way up above north, and then it's 1, 2, 3, 4 layers down in the danger zone. So it's getting worse. I can honestly say yes, it's getting worse. And you know, if anyone says, oh, we've healed the ozone hole, that's a lie. I don't know. You know, people don't know. They're not watching it like I am and like we are. And here's the Arctic ozone, and we've got this hole over Novaya Zemlya, the Kara Sea, Barents Sea, in Russia. This is in the aqua, and then the greens, and all the whole North Pole area, and coming across to Russia, and then Canada, and the western U.S. And methane, high methane readings or methane levels will eat away at the ozone. Also, sulfur dioxide, high sulfur dioxide readings will eat away at the ozone. And smoke from wildfires will eat away at the ozone. And radiation from the sun, and also nuclear radiation will eat away at the ozone layer. Here's the global view and all the greens. That's well below average or a good number. And then we see a thicker area just around surrounding the Antarctic area. It tends to gather like that. And then a little bit thicker in certain areas in the northern hemisphere. But we're losing the ozone layer, and that's not good. Okay, here's the smoke for today. You can see a big difference up here from Canada. Alright, so here's Africa. This is from the Congo. Here's Brazil. And here's North America. And then here's North America close up. And here where fires are still burning in Canada, it's a lot less, see? And the smoke is a lot less. It's still coming down over the U.S. a little bit, but not that much. And virtually no smoke on the west side here in the U.S., which is a blessing. I mean, this year has just been such a break from all that smoke. Seriously. Okay. So we got that. And now we're ready for sea ice. And just get this set up and ready. And I'm going to take a break, and then I'll come back and record the sea ice portion of the show. Don't go away. Okay, I'm back, and now we'll move into the sea ice part of our show. And we're going to start with a slideshow from Climate Reanalyzer. These are images I download every day. And here we are on sea ice concentration and snow cover for today. And if we zoom in, we can see the white on the land. That's snow. See, all the way up here, we've got snow in Alaska, Russia, a little bit on Novaya Zemlya, Taimyr Peninsula, and so on. And then here's the sea ice, and where you see in the darker blue, that's where it's not as concentrated and the water is showing through. And we can see the Beaufort Sea is pretty much open. All of the Russia coastline is open, and this is This is the East Siberian Sea. Here's the Laptev Sea. We've got a band of ice coming down just parallel to Severnaya Zemlya, and then it's collapsing just south of that, and all around the North Pole it's collapsing. So it's melting in on this extent as well. On the east side, Greenland's open, except for just right at the top or north end and in the nearest strait. So let's see what happened this week. Here we were last Sunday, and there was a little wisp of ice here in the Beaufort Sea and a little more in this East Siberian Sea. So let's just click through. Here's last Sunday, the 3rd. Here's Monday. That's a big change, isn't it? Tuesday, Wednesday, and we can see this west edge melted in quite a bit there on Wednesday. Thursday, Friday, look at that. Look at the difference. So it's melting on the interior. So back to Thursday, but look at the change into Friday. See, it's thinning way down and collapsing there in the interior. Here's Saturday, and here it is today. So we can see the collapse coming in north of the North Pole as well. And then moving on to our other models. This is from the U.S. Navy. This is Arctic sea ice thickness, and their latest data is from the 8th, which is Friday, and that's true for all of these models today. And our color ledger on the right, and the majority of the ice is in some shade of lavender or purple, which is 1 meter thick or lower, generally lower than that. The dark purple and moving into the dark blue, like up here in quadrant 2, that's about 1 meter thick. And then the bright aqua is 2 to 2.5 meters thick. We just have a little bit of that left. And then the darker aqua is about 1.5 meters thick. And so that's the majority of what we're seeing here. We're zooming in, and where you see whites and moving into light lavender, it's just barely there. It might as well not even be there. And you see the whites peering through in through the lavender. This is open water. Where we see the whites, that's open water. And so our thickest ice, what we have left, is just above Greenland and just above Canada here, and it's got a little dip in here where it's breaking up and coming apart. And we've got a little line of red along the coast of Greenland, and so that's the thickest right there, red. The bright red is about 4 to 4.5 meters thick. Green is 3 meters thick, so a little band of green there. Here's a little red here in this tributary, which I'm kind of surprised of seeing. And these tributaries are pretty much opened up The Baffin Bay is open. Here's the nearest strait. It's almost completely open. There's virtually no ice here on the east side of Greenland. And here's Svalbard and the east edge of the ice. Here's Franz Josef Land and Novaya Zemlya. Here's the Kara Sea, Barents Sea. Those are open. Here's Severnaya Zemlya, and we've got a little bit of ice on the right side, and then here's this piece in the Laptev Sea, and then here's where it's collapsing down towards the North Pole. So let's look at, here's the 30-day animation, and this was updated to the 8th, so the forecast goes out to the 15th, which will be Friday coming up. So the data goes back 3 weeks, and the forecast goes from Friday to Friday. Or from Saturday to Friday. So it's still melting, and we can see it's kind of squishing down, being pressed down thin as a thinner line of the thicker ice along Canada and Greenland. See, quite a bit happens in this forecast period, still in the melting period, and sometimes when you see like a chart with the extent ice kind of expanding a little bit, it's because the ice has melted here and it's just spread out. It doesn't mean that it refroze and it's growing back. Not at this point in time. It's not refreezing yet. This is still melting, and the sun is still up. It's getting lower towards the horizon, but it is definitely still up, so the water is still absorbing radiation and heat and not reflecting it back from the surface. Okay, here we are at the end of the model, so for next Friday, and we're seeing whiter areas, so lighter lavender, as this continues to melt and collapse there, and we're seeing the bright here. This is in the Lincoln Sea, and see the kind of the V shape kind of dividing the ice here, and the aqua is just kind of squishing down, not much left, and at the end of the melt season is just going to be this area with the thicker ice. So let's go back, and that was yesterday. So let's see, here's where we are today. So we can see the movement of the ice. Watch, you can watch it being pushed towards the coastline. That's from the ice drift. We can see it exiting here through the Fram Strait, and it's also exiting as it's pushing down to the left and out through these tributaries. So let's click through. So here we are today, There's Monday. You can see the movement. Tuesday, Wednesday, Thursday, and Friday. So, yeah, lots of melting going on. Thinning more than anything here. Okay, here's the Beaufort sea ice thickness again for the 8th. So Alaska's down here. Here's Canada, and this ice, they're counting it on this model, but remember this was the 8th, and that was, well, 2 days ago. So let's see what happens in the forecast period. And we're in a transition with the model. That's why it keeps jumping around. Once we get past the transitioning with the model, I think it'll hold. But why is it putting in this frame here? Unless it's going to be the new model. I don't know. Okay, here we are at the end. At the end of the forecast period on the 15th. And just thinning more white areas. And I'm not seeing any refreeze yet, even in the forecast period. Here's the Antarctic sea ice thickness again for the 8th. Got a little refreeze on the extent here in the Ross Sea. And more aquas showing up as it's thickening around these coastlines. And here's the majority of the thicker sea ice here in the Weddell Sea. Aqua. But most of the ice is like in the purples and dark blue, so not very thick. It doesn't get very thick down here. And then normally during their summertime, most of it melts, and notice it's on the outside of the continent instead of being inside. And so most of it does melt in the summertime, and then it refreezes during their winter time. And the 30-day animation. Again, the forecast goes out to next Friday. So I'm thinking it's kind of leveling off and just kind of getting settled. And this will reach maximum extent around the same time that the Arctic reaches minimum extent. And here's the Ross sea ice thickness. So Ross ice shelf is right down here at the bottom. Here's the Ross Sea, and this model now is reflecting the same ledger as the others are, with going up to 5 meters thick on the dark red, which is just a little ribbon over here. So most of this again is around 1 to 1 meter thick. Yeah. Then you've got some aquas on the sides here. And see their model changed. So that was at the old model where it started out with the aqua. their chart was different then. And then they put in the little frame here. I don't know why. So we've got thicker ice moving in here from the right, from the coastline. But just kind of holding, not changing a lot. Alright, here's National Snow and Ice Data Center. Their latest data is from Friday the 8th. And this is Arctic sea ice concentration. And so this corroborates what we're seeing on the Navy model and Climate Reanalyzer. Anything in blue means it's melting. And the darker the blue, the more it's melted and already come apart and less concentrated. And the white area is very little white, meaning fully concentrated, meaning no breaks in the ice. So, see, it's even melting here, just above Ellesmere Island. See the blue there coming down, and darker here, just south of the North Pole. So, I don't know. I mean, it just depends on, what kind of weather we have in the next couple of weeks as to when we'll reach minimum extent up here, and also the water temperature. And the brown line is the median. You can see we're well under that. Here's the extent chart for the melting. And they're showing it kind of flat lining. And that's only because, like I said, the ice is spreading out. The pieces are spreading out as it's coming apart, and so that makes the extent larger than it would be normally. It doesn't mean that there's more ice, that's just how they count it. And here was 2012, we're still above that, and here's the median, well below that. Here's the Antarctic. And here's the refreeze extent chart. And we've set record lows this year. This is this year. And it had taken a higher angle up this week. And now it looks like it's kind of leveling off. And well below last year. And there's the median. Here's Greenland. This is the daily melt. This is for the 7th. This is the latest data on National Snow and Ice Data Center. And we've got a little bit of melting here on the southwest edge and a couple of dots up on the north side. And here are the cumulative melt days for this year. And just getting darker. See, on this west side, look at all this melting. This whole southern part experienced anywhere from, looks like, about 20 to 80 melt days this year. And the white area had no melting so far this year. So that area is getting smaller every year. Here's the extent chart. And the dotted blue line is the median. And we're just even. See, just right here. Just even with the median right now. And it usually flatlines by mid-September, and then they end in October on the reporting until then they pick it up usually in April the following year. That's all of those. Okay, now we get to go to NASA Worldview using my VPN in order to get onto the site. Without it, it's just totally black, like nothing shows up. That's how it's been all week. And same thing for Wednesday when I did my midweek update. I had to load my VPN. Virtual private network. So, because some things are just blocked in different countries. That's what I've noticed. And then, but why would NASA Worldview be blocked for the U.S.? That makes no sense. But it is what it is, and so now we're putting the VPN to good use. So I'm going to refresh and get the latest data. Here we are today on the 10th in the Arctic region. Oh, I want to just quickly show here in the Atlantic. Here's Hurricane Lee today. See, it's humongous. Here's the eye right in here, and here's the bands going out. This is the area. All of this is rain, and so as this approaches anything, they're going to be getting rain, and then where it gets most dense, of course, it gets higher winds and more rain. It's picking up this warm water right now in the Atlantic, and this is Puerto Rico right down here. Looks like Puerto Rico is going to be spared, and according to the two models that we looked at, it's going to go north about right over here, and spare Florida and this east coast, and then it looks like it's going to make landfall up in the northeast and up in Canada. So we'll see what happens. And then here's Margo, Hurricane Margo with a T. It's picking up steam, but it's in the middle of the Atlantic, and I don't think there are any islands around that are going to be affected from that. Okay, let's move on. So here we are in the Arctic, and you can there's still some smoke here from the Canadian wildfires. Not that much, though. It's a lot less. It's gone way, way, way down. And Lots of clouds today. Seems like Sunday is overly cloudy. So let's go through our models here. Sea ice concentration, and turn on the blue marble layer so we're not distracted. And wherever you see the greens, that's open water. So this is all melting. See, this isn't collapsing really. See here, huge areas collapsing north of the North Pole, and also this area south of the North Pole is collapsing. And normally we don't see this, in the years I've been reporting on the sea ice, normally we don't see it open up down here. Normally we see this area as pretty solid from Greenland all the way across this Canadian area, but not this year. Not this year at all. So let's go back to last week, the 3rd. So here we were last Sunday in our show. So big collapse going on there. So we'll click through. Here's Monday. Look at the big hole there by the North Pole. Tuesday, Wednesday, that changed. Thursday, wow, look at this opening up here on Thursday. Okay, here's Friday, and then it opens back up here on Friday. It's Saturday. Look at this, all this melting. And then today. So lots of melting going on. Alright, so we'll get rid of that layer and that layer, and now we'll just go in on the satellite view and see what we can see. One thing I noticed with using the VPN, and I'm on Google Chrome instead of Firefox, whenever I shift positions, it takes about a second for everything to come into focus. So it's not just instant clearness. So starting here in the Lincoln Sea, see all this open water right around the coastline of Ellesmere Island, and here's all the ice, this ice in the nearest strait. This is exiting here. It's being pushed through this nearest strait, and then it comes down. Here's a cloud, and then see, it's dissipating by the time you get to the other end of the nearest strait. So let's see, there's yesterday, day before. So I think that's a pretty good view. You get the idea that there's lots and lots of open water here. And then here's Greenland. We've got clouds here. Here it was on the 8th. Here's a better view. See the ice broken up here at the coastline. See this? And look, very little snow on land. I mean, it's just like bare rock. See, and then here's the ice sheet. See. So this was the 8th. So you can see it's open. There's no ice down here. Here's the 9th yesterday. This is a good view. See. And then back to today. Here's Svalbard. Right here. It's open. No ice around there. And here's the ice edge. You can see it through the clouds. And see how it's all broken up. So you can see the ice pieces expanding as it's coming apart, and so it gives a false reading of either the extent holding or growing, when in actuality it's less ice. And we can see through the clouds here. See the darker area? That's open water. See. So wish we could see that hole just south. I think it's under here. Yeah, see, look at that. And we're looking through a cloud, so lots of open water there. See, look at this. You can see the ice pieces. Actually, as the sun gets low on the horizon, the model doesn't reflect as much, and so we can actually see the ice a little bit better at the beginning and endings of the season. Look at this. Look at this. See? Pieces. Here's the North Pole, and look, you can see the ice right here. Yeah, what surprised me for the longest time was that this thickest ice was never at the North Pole. It was actually further south, down towards Greenland and Canada. So let's see. Oh wow, look at the leads opening up here. This is on the west. So yeah, this is still in melt mode. Where's the hole? Let's see. Right here. It's big. Look, right there. Yeah, you can't see it. It's kind of got a cloud over it. Yeah, clouds. This is a good view here on the 7th. I've got hiccups. See, look. See the open water there? So this is a good view on the 7th with not very much cloud cover here. So it's ice cubes and all the open water that's absorbing heat rather than reflecting it. Look at that. That's a lot. Okay, let's go back. Okay. Yeah. Coming on up this east side. Where were we? Here's Svalbard. Here's Franz Josef Land. Here's the ice. Look at this. See the breakup? And spreading out. Lots of open water. Here's Komsomolets. So the billowing of methane is right around this area here. Here's Vogelhof ice cap. That's today. Okay. Can't really see anything much. Just really cloudy. So, this Kara-Sea is open. Here's Novaya Zemlya. Here's the algae. Look. It's moved out. Spreading out or something. Here's more. See the green? I'm sorry about my hiccups. See the green? We've been tracking this big thing of algae all summer. Here it is, see? See the green? This is in the Barents Sea. Okay. Moving on. Okay, we saw this. Here's the ice. Look at how that's. See, they're counting all of this as extent. Even though there's all that open water. How can they do that? I mean, in good conscience. Okay, here's the Laptev Sea. This is open. And here's New Siberian Islands. Here's the East Siberian Sea. So this is open. So that East Siberian, the ESAS, East Siberian Arctic Shelf, is right in this area, in the Laptev Sea. But it's it's ice free. There's no ice here. See? Look at that. Anyway, I mean, the ice that's here is just a little film. But they count that. Bering Strait. Okay, this is all open. Chukchi Sea. Here's the Beaufort Sea. It's open. See the little film of ice as it's spreading out. Melting. That's melted and spreading out. And here was some thicker ice along the coastline, and that's going to be breaking up. And then here's Canada. Here's Ellesmere Island. So I'm trying to get a peek at the ice here. Okay, this is yesterday. See the cracks. So this is melting. This is what's left of the thicker sea ice area. And see these long lines, they're called leads. And those melt first. That's the thin ice that's formed between the pieces of thicker ice. So those go first, and then the pieces melt as they slosh around. Let's see. So here's today. So you get the idea here. Now let's go to the Antarctic. And this black area in the center, this is the area that's still in the dark as the sun is coming up, and the sun is still very low on the horizon, and so we can see all the coastlines are now in the sun. And here's the Western Peninsula. I hate hiccups. I'm just it is what it is. Okay, and this is main area of interest that everybody's watching. Pine Island Glacier and Thwaites Glacier. And here's Pine Island, and this is open water here. This never refroze. This right in here. This is the edge of the glacier where the latest calving had been, and this ice is breaking up. If we look at here from the 8th, you can see the open water. See, and see the ice melting here. But there are active volcanoes under a lot of this area. I think they found 99 active 99 volcanoes under the Antarctic. So if you've got an active volcano that's underneath a glacier, that glacier is going to melt. That's the idea. So here's the 8th. Here's the Thwaites Glacier. And here's the tongue. This is open water just below that. This is all open here. Here, you can see through the cloud that open water. Let's see open water here. Okay, let's move around. Here's the Western Peninsula. And this area is a thicker sea ice, the aqua that we see on the models. The Larsen ice shelves are along this Western Peninsula. What's left of them. A is collapsed, B is pretty much gone, C is, 2 or 3 years ago, a big piece calved off right here. And this line is where it used to come out to the ice shelf, but this is sea ice now. Yeah, we followed that iceberg. Whenever a big iceberg calves off, I like to follow it and see where it goes. And we've got, see, this is the Ross ice shelf, and there's open water right next to the ice shelf. And you can see the depth here. It's like a 3D almost. But here, this rectangular piece, it calved off a couple of years ago, and we saw it make its way out into the ocean and come apart. So this is the Weddell Sea. And right over here, this is the Brunt ice shelf. And remember, this calved off earlier this year. Big piece calved off, and I'm not sure where it is. Down here somewhere. This is sea ice here. Can't really see the cracks, and this area calved off too 2 or 3 years ago. So we've got some open water around here, and this is an area where we constantly see methane coming up on this ice shelf and in the ocean next to it. See the ice? Y'all are just gonna have to tolerate my hiccups. I apologize. At least I'm not coughing and wheezing tonight. Okay, here's the north end. And see, the ice doesn't go out very far on some of these. Okay, here's the Amory ice shelf here, and sea ice is back here. See, it's thin here. And this one calved off, I don't know, a couple of years ago. Back to today. Here's the east side, and then right down here is another glacier I'm tracking. This is called the Totten Glacier, and it's got a tongue down here, and this has been open. This area did not refreeze during the winter time, but we're seeing some little ice streams freezing now. And see over here, open water too. So another area with warm water. And here's the Ross Sea, and here's the ice comes down there. And if we zoom in, you can see the melting. See how thin it is over here. Here's some thicker ice. And this is Ross Island here. And this mountain right here is Mount Erebus. It's an active volcano and puffs away. And here's the shadow from the volcano, and then there are two more volcanoes, but Mount Erebus is the main one. Right up here on this tippy point is the McMurdo research station. There's a shadow, I'm thinking a tower, probably communications tower. Shadow there. And here's the Ross ice shelf, and we can see open water. See, right next to the ice shelf. And then coming around. Here's some more open water. See? Look at this. So all areas where it's got to be warmer for the ice not to freeze. See this big break? Open. Open, open. So there's that. Now I'm going to close that out. We're almost done. We'll briefly go over earthquakes for the week, and of course y'all have heard about the big one in Morocco. A couple of days ago was 6.8. Latest death toll I heard was over 2,000 people. So we need to be praying for them, and they're still having aftershocks. So in the last 24 hours, it's calmed down about 210 earthquakes worldwide. We've got a mixture of 4s and 5s here. 4s here in South America. And if you think about what I showed you on the sulfur dioxide, how it came down along this west coast of Canada. Oops, I meant to go in, sorry. West coast of Canada, and here's the Juan de Fuca plate where it connects, and then it spread out from this subduction zone, Cascadia subduction zone area, and it went straight across the U.S. here. And another part went down. So I don't know. I mean, with it going straight across like that, I don't know. I don't know if it's from plate movement and it just got caught up in the jet stream, or, like I said, it could be sulfates falling out. Or they could be spraying, because one of the things they were going to do is spray sulfur dioxide up in the atmosphere to try and block the sun. So, bad idea, I think, but what are you going to do? 2 here at Roundup Mountain. We've had a lot of activity up here just east of Shasta Lake this week. Let's see, I just want to look for daily things first. So these are not huge. Okay, what have we got over here? Just south of Japan, 5.3. Here's Morocco. Here's a 4.2. And so let's go to all magnitudes, 7 days. And we're showing 1,918 earthquakes worldwide this week. We had some big ones. First of all, here in Morocco, right here, the 6.8, and this came in on the 8th at that was 3:11 p.m. Pacific time. So add 7 hours and that'd be UTC time. So right around midnight. And we also had a 6 down here off the coast of Chile, 6.2, Coquimbo, Chile. And if we zoom in, see it's just in the bay there. So even just being that far off the coast really buffers it, buffers all the shaking. And see. Here, north of New Zealand, 6.6. This was on the 8th. And this is just north of New Zealand. And see, we've got 19 in this picture. And we've got mainly 5s and 4s. So this is Fiji and Tonga area. And then the Indonesia, right here in this little bay area, 6.0 near Palu, Indonesia. That came in yesterday. So quite a few 6s, lots and lots of 5s, and lots of 4s. We had movement here all around this Cocos Plate, and here further south at 5.8 Central East Pacific Ridge, 4.6 Galapagos Triple Junction, 5.8 at the north end of the Cocos Plate. And see, this plate is connected to the Juan de Fuca Plate by the San Andreas Fault Line, which becomes the Imperial Fault Line at Salton Sea in Southern California. Look, we've got 2 here, 5.6 and 5.8, and then more along the coastline there. So that's been active, which means we should see plate movement on the other end. You know, that all of this activity could be triggering sulfur dioxide release, I'm thinking. Okay, here's the Juan de Fuca Plate, 3.1, 3.3, 2.8, and then here's quite a few at the fulcrum point. And then over here, just east of Shasta Lake, and Mount Shasta is just northwest up here. And we've got big cluster 28 here this week. And the reporting station is Fall River Mills or Bernie, California, all kind of in the same place. And it all started with this 5.0 that happened on the 8th. And sometimes we see earthquakes up here, but it's not every day. And then right after that was a 4.3, and the rest are these 2s and 1s aftershocks. So 28 total here. So that's pretty good sized. And let's see what else. Just more of the same. You'll see all the, this is the San Andreas Fault Line here, and look at this. Oh, here, this is the geysers, 207. Yeah, that's par. Searles Valley Ridgecrest, see, they're still going strong. And so on. So that's my report for tonight, and I always like to bring things back to a spiritual perspective, because we're talking about the end times, not only from a climate standpoint, but from a biblical standpoint. I do believe we are in the end days, and that people need to get their spiritual houses in order and, get right with God and Jesus. If you haven't given your life to Jesus Christ, to do it now before it's too late, so that you won't get trapped by Satan. And so, anyway, we're reading out of the book of Tobit, which is part of the Apocrypha, which is books of the Bible that were considered to go into the Bible, but for whatever reason didn't make it in. But they have wisdom too. Tobit chapter 6. And as they went on their journey, they came in the evening to the river Tigris, and they lodged there. And when the young man went down to wash himself, a fish leaped out of the river, and would have devoured him. Then the angel said unto him, Take the fish. And the young man laid hold of the fish, and drew it to land. To whom the angel said, Open the fish, and take the heart, and the liver, and the gall, and put them up safely. So the young man did as the angel commanded him, and when they had roasted the fish, they did eat it. Then they both went on their way till they drew near to Ecbatane. Drew near to Ecbatane. Then the young man said to the angel, Brother Asarius, to what use is the heart and the liver and the gall of the fish? And he said unto him, Touching the heart and the liver, if a devil or an evil spirit trouble any, we must make a smoke thereof before the man or the woman, and the parties shall be no more vexed. As for the gall, it is good to anoint a man that hath whiteness in his eyes, and he shall be healed. And when they were come near to Ragus, the angel said to the young man, Brother, today we shall lodge with Raguel, who is thy cousin. He also hath only one daughter named Sarah. I will speak for her, that she may be given thee for a wife. For to thee doth the right of her appertain, seeing them only art of her kindred. And the maiden is fair and wise. Now therefore hear me, and I will speak to her father, and when we return from Ragus, we will celebrate the marriage, for I know that Raguel cannot marry her to another according to the law of Moses, but he shall be guilty to death, because the right of inheritance does rather appertain to thee than to any other. Then the young man answered the angel, I have heard, brother Azarias, that this maid hath been given to 7 men, who all died in the marriage chamber. And now I am the only son of my father, and I am afraid, lest if I go in unto her I die, as the other before. For a wicked spirit loveth her, which hurteth nobody but those which come unto her. Wherefore I also fear lest I die, and bring my father's and my mother's life because of me to the grave with sorrow, for they have no other son to bury them. Then the angel said unto him, Dost thou not remember the precepts which thy father gave thee, that thou shouldest marry a wife of thine own kindred? Wherefore hear me, O my brother. for she shall be given thee to wife, and make thou no reckoning of the evil spirit, for this same night shall she be given thee in marriage. And when thou shalt come into the marriage chamber, thou shalt take the ashes of perfume, and shalt lay upon them some of the heart and liver of the fish, and shalt make a smoke with it. And the devil shall smell it and flee away, and never come again any more. But when thou shalt come to her, rise up both of you, and pray to God, which is merciful, who will have pity on you, and save you. Fear not, for she is appointed unto thee from the beginning. And thou shalt preserve her, and she shall go with thee. Moreover, I suppose that she shall bear thee children. Now when Tobias had heard these things, he loved her, and his heart was effectually joined to her. Tobit, chapter 6. So, the young man had the companion of an angel on his trip to protect him and guide him. I think the angels are all around us and are helping us, and especially if you call out for help, God will send his angels to help, to heal, to lift up, for all kinds of things. The miracles happen every day. We just don't know it. And if you're under God's wing, you'll see the miracles more and more. So I love you all, and I'm praying for you, and hope everyone has as good a week as possible. And Lord willing, if all goes well this week, I'll be back here next Sunday night giving you another update. So God bless you. Go in peace, and I will talk to you soon. Good night.